Welcome to lesson 9.3, Connecting Graphs and Rational Equations. This is going to be really quick, short little lesson for the end of chapter 9. As we have seen in our last couple of chapters, the last section in this chapter is all about taking everything we've known, throwing it all together, and solving equations involving whatever we've just been looking at. And so there's nothing different here. One of the things that we want to be really careful about is our non-permissible value. So we have to be careful for extraneous roots of these equations. And so one thing that I haven't always been doing, but I'm going to make sure that I do right away here, is I'm going to look at that equation. I'm going to look at both sides in the denominators, and I can see that I get non-permissible values at x equals -4 and x equals +4. And I have a difference of perfect squares there on the left-hand side. All right, move on to the solving piece. We know that we want to bring our unknowns up into the numerator. I'm going to be a little smart here. I'm going to pay attention to the left-hand side, and I'm just going to multiply by x minus 4 on both sides first. So I'll get x squared minus 8 times x minus 4 equals, well, if I multiply the right-hand side by x minus 4, that's just going to leave me with a 1. And the reason why I didn't multiply by x squared minus 16 is because I know, as I previously said, that is the difference of perfect squares, and I'm going to do a little bit of factoring. And when I do a little bit of factoring, I see that I get the terms x minus 4 over x minus 4 canceling out. Now I can multiply both sides by x plus 4. So I'm left with x squared minus 8 on the left-hand side. I get x plus 4 on the right-hand side. Move everything over to the left-hand side. We get a quadratic, so we get x squared minus x minus 12 equals 0. We can factor that relatively easily. So I get factors of x minus 3 and x minus 4 and x plus 3. Right? That gives us negative 4x plus 3x gives us our negative x, and then negative 4 times 3 gives us our negative 12, of course, and that gives me solutions of x equals 4 and x equals negative 3. Now, of course, we know that that solution does not exist because it is a non-permissible value, and I'm left with a solution of x equals negative 3. If I jump over to Desmos really quickly and take a look at what's happening, I can see my solution there at x equals negative 3. And what's really cool about this, we know that x equals 4 is not a solution because it's a non-permissible value. But what's happening, the two graphs, the x squared minus 8 over x squared minus 16 and the 1 over x minus 4, the reason that's not a solution in those graphs is because it's a vertical asymptote for both of those graphs, and so we can see that graphically. I, of course, could check that algebraically as well. I can very quickly see if I shove in an x equals 4 into both sides of the equation that I get undefined equals undefined, which doesn't show me anything, right? It just shows me that I'm dividing by 0 on both sides of the equation, and I could double check to see the value I get if I put in x equals negative 3 to show that it is actually a solution. All right, so that is it for this video. As we move forward, we could have any polynomial over any polynomial. We might have to use rational root theorem to work our way through it. So the questions can get more complicated, but they don't really get harder. We've seen what we need to see. The big thing that we need to pay attention to is to make sure we're paying attention to those non-permissible values and we're checking our solutions. All right, there's nothing else for you to do. Make sure you have any questions ready for me.